Here they are.
Welcome, Trigonometry. This is Mr. Tivnan, here with my son Joey, and we are making a recording right now to show you how to solve a trig equation. Right, Joe?
Well, yeah, I knew that was.
Yeah. So I'm going to write the equation that you saw on today's quiz. And this is by the way, I'm doing this from home. It's about 7:30. I'm just about to start watching the Celtics. So I'm trying to squeeze this this little thing in now. Okay, so the problem on the quiz, number one, everyone seemed to have trouble with, was tangent of x plus 1 is equal to the square root of 3. Let's see, what was it? Plus the square root of 3 cotangent x? Yeah, I think that was it. Okay, so when you start to think about this problem, you've got the problem that you have a tangent and a cotangent in the same equation.
Can you please open this?
So what I want to do is try to get this all in terms of one trig function, and that would be, I think, the best choice would be to make it all in terms of tangent. Because you have a cotangent here, I can basically multiply both sides of the equation by tangent of x. And same thing to this side, tangent of x. Okay, when you do that, you end up distributing on the left side. You have tangent squared x plus tangent of x equals the square root of 3 tangent of x plus, and this just becomes the square root of 3 because tangent times cotangent equals 1, and we have that square root of 3 there. So here we go. We have all tangent now. So now, when you look at this equation, you notice that there's a tangent squared x and a tangent of x, and there's a constant root 3 in there. So this is a quadratic, and when you have a quadratic, you want to have one side of the equation equal to 0. Okay, so what I'm going to do, let me change the color. I'm not crazy about the red. So what I want to do is basically subtract this right-hand side. Try that again. I'm trying to make a circle. Doesn't matter. Okay, what I'm going to do is, a nice feature of this program that I'm using called Dabbleboard is I can make copies. So I want to take this piece and subtract it from both sides. So that means I'm bringing it to the left-hand side and writing a minus in there. And I'm taking this over here, that's root 3, and also subtracting it from both sides. So then I have nothing on the right, so I'll write 0. Okay, now, when you look at this, it's a quadratic. You could use a quadratic formula. You might have to combine a few things, like these two middle terms. So it's an ax squared plus bx plus c form. But I don't think we have to do that. I think this can be factored. So what I'm going to do is write, bear with me. Okay. What I'm going to do is write tangent of x, close parentheses, another parentheses, I'm going to write a tangent of x, close parentheses, equals 0. Now we're going to fill in this missing stuff here. What goes in here and here? Can we factor it? That's really the question. So, well, I got a negative square root of 3 over here. And since these both are identical, tangent x and tangent x, it doesn't really matter where I write minus square root of 3. I suppose it could be plus square root of 3 and minus 1, but let's see. To check this, I have tangent of x on the outside. I have negative root 3 tangent of x on the inside. Well, that's pretty much what we have up here. Again, tangent of x on the outside, I'm kind of looking at it as a foil, and negative root 3 tan x on the inside. So it seems to work. So if that's the case, we can now use a zero product property, meaning we can set each factor equal to 0. By the way, you can see what happens is it's kind of sensitive, and I can actually type in this program if I wanted to, but I don't want to right now. So just delete that. So tangent of x minus the square root of 3 equals 0. And over here we have tangent of x plus 1 equals 0. And now we can solve each one separately. So I want to solve this equation. I have the tangent of x equals the square root of 3. So where is the tangent of x equal to the square root of 3? Let's see. We have, that would be 60 degrees or pi over 3. And a positive. Tangent's positive in quadrant 3 also. So that would be 240 degrees. That would be 4 pi over 3. On this side, this factor equal to 0 becomes tangent of x equals negative 1. There we go. And where is the tangent equal to negative? First of all, negative values of tangent are in quadrants 2 and 4. So that means that if it's 1, that means it's a 45, 45, 90 reference triangle in quadrants 2 and 4. That would give us 3 pi over 4. That's quadrant 2. And 7 pi over 4 in quadrant 4. And there we go. It's solved. We could check these values back into the original just to be sure. That's always a good idea, although I don't have time to do that right now. We didn't square both sides of the equation at any point, so we shouldn't have extraneous solutions. Only when you're squaring both sides will that occur. So that's it. Thank you for watching, and I'm out of here.